Let's solve another log function here. Now, this particular setup, I notice there's two logs on one side of the equation and no logs on the other. Again, I'm going to have to, my variable's inside the log, so I need to figure out how to get that out of there. So I'm going to, again, apply this log rule because I want to condense the logs as much as possible. But again, the rule that says if I'm subtracting two logs, which I am, I can always rewrite it as a single log, like so. And I have that exact situation going on here. So I'm going to take log base 3. And now this first expression goes in the numerator. And what I'm subtracting here, this expression goes into the denominator. And this whole thing equals 2. So all I've done is apply this rule here. Next, I need to again free this variable x from inside the log. How can I do that? Well, there's no longer a log on this side, but I can change it to exponent form. So all I'm going to do right now is apply this rule. It says, look, if I have log base b of x equals y, I can rewrite this in exponent form as b to the y equals x. So again, input, output, reverse, input, output. And that's what I'm going to do here. So now here's my base is a 3. So 3 raised to this to 2 should equal, so again, a big circle, b to this power equals x. So here, 3 to the second power equals that entire expression that I see inside here. And now I have, again, a rational function. So I just need to get it so this variable x is not sitting in the denominator. And the only way to do that is to multiply both sides by this denominator. Again, here, these two cancel, or x plus 4 is a 1. So if that's a 1 times anything is the object that we're multiplying by 1, and it's 3 plus 2x. Here I'm going to distribute, I get 36, and 9 times x is 9x. And now I went from a rational back to a linear. I just got to solve a linear equation. Subtract 2x from both sides. Subtract 36 from both sides. So I get 7x is equal to negative 33. Divide by 7. And I get what x can be. So roughly speaking, 7 goes into 33 4 times evenly. And what's the remainder? 7 times 4 is 28. And that leaves me 5. So it's 4 and 5/7. And this whole thing is negative. And that's what x is approximately. Well, not approximately, exactly. All right. And is that a solution? Well, I'm already looking at this right here. And what does this say? I need x plus 4 to be greater than 0. Subtract 4 from both sides, and I get x must be greater than negative 4. So the domain of this function must be greater than negative 4, and I don't have that because here's 0, here's negative 4, and this one is negative 4 plus 5/7 is further out. So just for this function alone, it requires this type of input. I don't even have that for this. This value is, here's negative 5. So this is somewhere here, 5/7. So yeah, this is definitely not a solution, even though I got it to value. So there's no solution to this. equation.